This recording will be on Chapter 14, Java FX Basics. We're going to be where the author discussed the differences between Java FX. So let's move on to the next slide. Now this is just
Alt was
taken from
was introduced when Java was first introduced
commercially.
You create
your first Java FX application.
And Alt stands for Abstract Windows
Toolkit. So here's a different thing you need to import, and we're going to talk about what these things
or at least computer
are.
platforms,
The
really independent.
The window that you
Meaning
want to display.
it was
needs
very
to extend
difficult to
an
have
application
software
that was loaded,
or at least the
on
object needs
a
to extend an
PC
application
that could actually run
and then
off
that
of
class, whatever that
Macintosh.
class is,
Back then we're talking
you're going to
about
have
before
you're going to overwrite the
computers
start
became
method,
known
passing the
as
stage,
Macs.
primary
This is when,
stage.
Macintosh,
And inside this
also known as
code,
Apple
or inside this method, I have code.
So we're talking
where
about
I'm creating a
early
button.
90s.
Then I create a scene. We'll talk about what a scene is in the next few
Unix or
slides.
Linux,
I give the
platform.
window a
And in most
stage
cases,
is the window.
So
So
the stage
software
object is a
was
window.
incompatible. So I give the primary
So you
stage
can only
a
use
title,
software on a
and then I have to add a
specific,
scene to
platform.
the stage.
Again,
Because
we'll
of
discuss
that,
what the scene is
James
later.
Gosling, and then I have to show the
developed,
stage. This line of code, primary stage I
Java,
show, is what displays the
came up with
window.
this
You don't
abstract
do
Windows
this,
toolkit,
and it was
you
just
won't see anything.
Now
It
the
just
code
took
I have down
the
here is
graphics
commented out.
that was specific
You
to the
technically
machine
don't
it was
need
running
this.
on.
In his case, if you have an ID
Java
with
was-
limited,
he
limited
designed
support,
Java,
then
if
you
you guys
do.
recall.
When you do
designed
my
it
Java
primarily
FX
so that it
extends,
can
or I'm sorry, when you do a
actually
class
cross
that
that gap
extends
between
the
platforms. You want the
application,
first
and that
software
you override
plat-
your
device
start
and
method.
software
When you
languages,
run
can
it,
actually
it should call
be
this
developed, where
automatically.
you can develop software.
To do that in
on
JGrass, you have to
Macintosh
do the
machine,
build,
and then you can also
and
port
then
that
select run
software
as
on a
application,
Windows machine.
and that will
And then
launch
port that
this.
software on
If you
a
just
Linux
want
machine,
to run it the
everything will
normal
work.
way,
So the way
then
he
you
did it,
will
the way he
need the
designed
public
it
static
was,
void main
it
uncommented
would
out
only
with
grab
this line of
the
code
graphics
application with the big A
from
dot launch, and
the
you're passing in the
specific machine it
args.
was using.
So this
So of
method
course
here
is
in
a
the
simple
application
GUI library
class
it was
calls
very buggy,
the start method.
things of that nature.
Now Swing was a more comprehensive GUI library.
Let's talk
Now,
about
this was much more platform independent.
the whole
reason why.
structure.
Swing had
being,
its own
something to display,
or at least a lot more
display
graphics
JavaFX.
within its own GUI library.
So
So
it
a
wasn't
stage is a
gonna
window, and I
use
think the developers who came up with
graphics
JavaFX,
that
they must have a
were,
background in
specific to
or interest in
platform.
performing arts.
Because
Now,
I see this,
having
this
said that, now
stage
Swing
scene
came out
metaphor,
probably with late
being used
'90s.
where
The stage
and it
is
was your-
very useful
your-
for
I guess
the
your first
viewing
decade of,
area, and then the
this
scene is
century.
what gets. But there were
gets put
some
onto
issues with
the
Swing.
what gets
For
presented to the
example, you
audience.
really
You have
couldn't do
multiple
3D. I
scenes,
mean, they had a 3D
things of that
library.
nature.
So
Swing.
let's talk through this.
I
Your
played
stages
around
are
with
with
it.
couldn't
When we
get compare that to Swing.
The
Swing animation
was
frame was
or
hitting
JMS.
frames, depending upon what you're doing.
Sometimes it would
But the
work
stage
well.
is the
Other times
main
it was
window,
really buggy
and everything
and
gets
really
put inside
choppy.
the stage. And you
I don't
can use that
recall
title
if there
method
was any
to display the
capability
title
for
video
on the window.
And at that time,
Now, your
mobile
scene is an
technology
object
wasn't
what
that
it is
attaches
now.
to the
So
stage.
there wasn't
The
the set
nothing
scene available
method.
for mobile technologies.
So now you
came out
we
and
can
developed
create
Java
panes.
FX,
You don't have to create
and
panes.
Java
In the last
FX is
example, we didn't create a pane. We added something
much
directly to the scene,
better
and we put the scene to the stage.
enhancement
But
to
in that
Swing.
case, if you
In
in
fact,
fact were to
it's
run
so
that
much
code
better
and display, you have
that
a
Swing
one
is no
button
longer
that
being
takes up the
supported.
entire window. That's not really
So
useful. You know, when we look at the difference,
we're gonna
between
develop
alt
really
Swing and
Java
really nice
FX.
looking. When Swing was
UIs
introduced,
and
do that.
alt
We're
will
gonna
still be
have to
was still
add
being
this
used.
other component called a pane.
Now that Java
and a
FX
pane
has
is
been
a
introduced,
container class
they're no longer
that will hold all visual
supporting
components.
the previous two,
With a pane, you can
graphics
specify location
library.
and size of each component.
Java FX has
as well as
functionality for 2D,
specify
3D,
location, animation,
location
video,
of the
and
components
mobile,
and how big you want them to
specifically
be.
with mobile, you can do
And then
a
in
lot
most
of
cases,
slight,
we will be using a layout
interactions,
pane
which
class.
we'll learn about
and
interactions
then
in
attach that
chapter
to the
15,
scene.
and we'll talk about
But
that
Java FX
later.
is definitely the
With
graphics
the
library
pane, you
that,
can create nodes.
Java
These nodes
plans
are
to
visual
use and
components.
probably
A node
plans
can
to
be
use for a
anything
very
from a
long time.
button
So
to a
it's
radio
really
button, a
important that you learn Java FX. It's
checkbox
new.
button.
I think
A node can
it
also
was
be a label.
introduced
Node can
probably in the
be
late
text.
I think
Node can
2008,
be,
maybe 2009.
Almost anything you want to be visually displayed.
And I think
to
at
the
Kennesaw
user.
State, we
And
have
the best practice you guys can see down here is
discussed
we're going
Java
to
FX.
create a
in most of our
node,
classes. I think in
or
CS
create nodes,
232,
attach nodes to
this
the
will be our
pane,
second
attach-
semester,
or
teaching
panes,
Java FX. So you guys
attach the
are-
pane or
are
panes to the
in the-
scene, and then we
you guys
attach
are
the
ahead of
scene
the
to
curve
the
when it
stage.
comes to
That would be the best
learning
practice
Java
about it.
FX and
Now, and to understand how your a scene works and how to just lay things out in the most basic case, we have to talk about absolute positioning. Absolute positioning. You guys remember? I think it was chapter 12 where we talked about absolute pathing, where the location of the file was absolute to where it is, where it's sat on the computer. So the same thing works here in absolute positioning, where I can tell a pane or node to display itself that is specific to the location in the window area, okay? And we use this Java coordinate system you see on the left, where if this is my window, we have 0, 0 will be in the upper left-hand corner, and as you go horizontally, you increase in X. So this is your X-axis. And then as you go down, you increase in Y-axis. So let's compare that to the conventional coordinate system, where, and you guys have all seen this back in your basic math classes, where X to the right is increases, Y going up increases. In this case, X to the right still increases, but Y going down increases. And 0, 0 is the left-hand corner. And as you can see here, if I go 50 over, 10 down, I'm at 50, 10. And if I go 10 over, 50 down, I'm at 10, 50. So the X always goes first in front of the Y. It's pretty straightforward on how to do this. Now here's an example of how to use absolute positioning. Now again, we're not doing a layout class. We'll talk about a layout class shortly. And all I have here, and this is the example from the book, we're doing a show circle, and it extends the application. And we're just going to put a circle dead smack in the middle of the window. We have our scene, you guys can see here, at 200, 200. So we're going to set a circle, and the circle is going to be positioned at 100, 100. And we set the radius to 50. And if we displayed it, you would get a circle that's in the middle of the screen. And that's pretty much it. Now, there's two things to note. The first thing, I want you to see how I am breaking up my code. I have multiple methods that do one specific thing. At least I'm trying to get to do one specific thing. And the purpose of this is, and I may have explained this before, or at least try to introduce you guys to the concept of separating your code. And in object-oriented programming, we discussed this in chapter 10 and even in 11, where we discussed how to make sure we modularize our code and separate it so that there's levels of abstraction. So where we have methods doing, we have one method doing something, another method doing something different, and we put all the pieces together, we have our full picture. It becomes even more important when we do UIs, because we're going to be developing UIs with so many different components and so much functionality that you really want to make sure you practice separating your code. Otherwise, you can have one method or two methods that are doing way too much more than it actually should. When I was in industry, I think most organizations I worked in, if not all the organizations I worked in, had a policy where a method could not be written, or one method couldn't have more than, I think, 25 lines of code. I really encourage you guys to start thinking about how to do that. Yes, it is very easy to just write everything in your start method, but it's really sloppy and it's poor programming. It's very poor programming to do something like that. You really want to make sure you understand how to separate your code. So as you guys can see, we go in our start. I have this initialize method, and I'm initializing my nodes as well as my pane, my scene, and I set my primary stage, the title, and I set the scene. And then I initialize my circle from within the init method. So I take care of all the circle stuff here. I initialize my pane. I take care of that inside initialize pane, and I initialize my scene here. So these things are all doing something different. So that's the first thing you guys want to make sure you're trying to get an understanding of how to do. And of course, it's really difficult to do unless you design your code properly. And with UIs, it gives us the opportunity to design our code. So hopefully you're doing that. And then the second thing I want you guys to understand, if you were to run this code, you would not be able. We would get our UI, but if we decided to make our window bigger or smaller, the circle won't move. So I can make my window bigger, and then the circle would no longer be, depending on how big I make the window, the circle will no longer be in the middle of the window. And if I make my circle or my window too small, I can actually hide the circle, so the circle is no longer visible. So this is not really a proper way of doing it. Absolute positioning works in certain situations, but there are some limitations with it. Because the nodes are specific to the size of the window that's been set in code. And if you resize your window, then the nodes remain in their original position, which now makes your window may not look the way you want. So there are some options to resolve this limitation. You can disable the ability for the user to resize this window. You can just set that as a false. You'll typically see this for pop-ups, for things that or login screens, things that need to be small, that probably need to be set to a certain size, and you do not want the user to resize it. Another way of doing it is to do property binding, which we'll discuss later, and then we will discuss how to use relative positioning layouts to actually accomplish this with a little more effectiveness than property binding. But let's talk about property binding first. Property binding, and this is a key definition to know, is where you set a target object to a source object, and then where the change in the source will automatically be reflected in the target object. So if I change something here, which is my source, then it's going to change whatever this target object, because these guys are bound. So if I change the size here, it changes the size here automatically. I can't show this in PowerPoint, or at least I don't know how to do this in this version of PowerPoint. I know in the older version, I think it was the easy way of doing it. But this is from the book, The Show Circle Centered. I will also post this on my webpage. But as you can see, if you decide to implement this code and run it, you will get the circle, the stage, or the window with the circle in the middle. And if you resized the window, then the circle will continue to stay in the middle. So that does accomplish it to a certain extent. However, you will still see some issues. If you make the window really big, then it no longer becomes a circle. And if you make the window too small, you can still hide the circle. So there are still some issues with property binding. It's useful, but there are still limitations to it. So a better now another thing that's difficult with property binding, if we were to do it this way and we had a full comprehensive UI where we had multiple buttons, we had text and labels, things of that nature, we had a lot of visual components that we're displaying, and we want to do property binding for all those things, then it's going to require several mathematical functions. And that may be something that I think I'm finding that a lot of computer science majors, they chose computer science because they want to get away from math. So I don't know if this is something you would like to do. And then you will still, because even if you have these mathematical functions in play, the window can get so big that certain objects can obscure other objects or overlap other objects. So you may need to still set minimum and maximum values for your windows, which you probably won't know how to do without trial and error. So there are some limitations here. And the alternative is just let Java handle the resizing via layout panes. And we're going to discuss that in great detail coming up now. But before I do that, let's talk about what relative positioning is. So as you guys can see, let's say this green area is my window, and I want the button to be displayed in the center of the window. I can use relative positioning to say, I always want this button in the middle of the window. If the window is this size, keep the button here. And if the window is this size, the button stays here. And it's a really easy thing to do with layout panes. And in fact, I use layout panes every time I code. I must have developed over 100 UIs in my lifetime, and I've always used layout panes. So this is something I really encourage you to understand. Start talking about layout panes now. Matter of fact, we're gonna conclude this lecture, and then I'm going to go to make this a part 2, because layout panes are very important. I don't want to make this video too long, and we're already approaching 15 minutes. So I'll conclude the lecture here, and then we'll talk about layout panes in part 2.